Today, we're re-diving into one of the most exciting and transformative topics in the world of energy, how AI, digital twins, and blockchain technology are working together to reinvent the electricity grid as we know it. This isn't some futuristic fantasy, it's already happening across Europe, Australia, and beyond. So, let's break it down, step by step. For more than a century, power grids followed a simple model: centralized generation, one-way distribution, and passive consumption. But today, we're witnessing a revolution. Welcome to the era of smart grids, decentralized, bidirectional networks powered by data, artificial intelligence, and a rising wave of energy prosumers. Thanks to renewables like solar and wind, electric vehicles, and smart appliances, consumers now also produce and share power. This shift isn't just technical, it's cultural and environmental, pushing us toward cleaner, more flexible, and resilient systems. At the heart of this transformation is artificial intelligence. Utilities around the world are using AI for demand forecasting, relying on machine learning, and generative AI to predict when and where electricity will be needed down to the hour and neighborhood. This precision helps utilities avoid blackouts, balance renewable inputs, and even trigger dynamic pricing. By analyzing real-time and historical data, AI allows for smarter energy load shaping, ultimately saving consumers money while cutting emissions. AI also plays a major role in predictive maintenance, using sensor data from equipment like vibrations, temperature changes, or even acoustic signals. AI can detect subtle anomalies long before something fails. This reduces unplanned outages and extends the life of critical assets, saving millions in maintenance and repair costs. And when it comes to grid optimization, AI-powered systems are stepping in to automatically balance energy flows, predict congestion points, and even self-heal in response to faults on the network. Now, let's talk about digital twins, one of the coolest innovations in energy tech. A digital twin is a virtual replica of a physical system like a wind turbine or solar farm fed by live sensor data. It allows engineers to simulate real-world conditions, test new scenarios, and optimize performance without touching the actual asset. Imagine forecasting how a solar farm would respond to a week of cloudy skies or planning maintenance for a wind turbine before it shows visible wear. These models are not just theoretical. Tools like Deloitte's Optimal Reality platform are being used right now to manage infrastructure and renewable assets more intelligently than ever before. But here's where things get really interesting: the convergence of digital twins and blockchain-enabled peer-to-peer P2P energy trading. In a P2P setup, energy producers, whether homeowners with rooftop solar or wind farm operators, can sell excess energy directly to other users on a blockchain platform. This eliminates the need for traditional brokers or utilities to manage the transaction. Blockchain ensures transparency, enables automated smart contracts, and creates a secure, tamper-proof record of every trade. Think of it as eBay or Airbnb for energy. Real-world pilots are already underway. On Inishmore Island in Ireland, a hybrid of digital twins and P2P trading is being used to optimize local renewable generation. In Estonia, the WebPower platform tokenized energy transactions to allow citizens to invest directly in renewable power production. These examples aren't just experimental, they're functional systems that are changing how we buy, sell, and value energy. When we zoom out geographically, Europe and Australia are leading the charge. In Europe, regulatory frameworks are opening the door for decentralized markets, and smart meters are becoming the norm. Countries like the UK, Ireland, and the Netherlands are actively running pilot programs to test blockchain-based trading and prosumer participation. In Australia, the focus is on infrastructure resilience, especially in areas affected by climate change. Deloitte's digital twin solutions are being used to simulate and prepare for floods and natural disasters, ensuring critical energy assets stay operational when they're needed most. Of course, the innovation doesn't stop there. Cutting-edge research is pushing even further with frameworks like PI and NDT, which integrates physics-informed neural networks, reinforcement learning, and blockchain to optimize energy usage in smart buildings. These models are already achieving impressive results, up to 35% reductions in energy costs while maintaining high accuracy. But challenges remain, especially when it comes to blockchain scalability. The energy cost of consensus mechanisms, transaction speed, and balancing decentralization with security are still hurdles to overcome. Beyond the tech, there are big-picture questions we need to address. On the technical side, can we scale blockchain for millions of microtransactions per second? Can AI systems integrate with aging infrastructure that wasn't built to be smart? On the regulatory side, how do we define data ownership in a distributed energy system? Who's liable if an AI makes a wrong decision? And on the economic and social side, how do we ensure all consumers, not just wealthy early adopters, benefit from this transformation? So what does this all mean for the future? We're heading toward a world where electric vehicles feed power back into the grid, where buildings simulate their energy use daily, and where communities run their own decentralized microgrids. This is more than an energy revolution, it's a data revolution, and it's just getting started. If you made it this far, here is a question for you. Would you trust a blockchain-based platform to manage the electricity in your home? Let me know in the comments. I'd love to hear your thoughts. And if you're working in smart grid tech or know of a local P2P project in your area, drop a link or story below. Don't forget to like, subscribe, and share this with someone who's passionate about energy and technology. Until next time, stay powered up and stay curious.